Hey everyone, thanks for checking out this video. We're going to work through adding and subtracting situations that might be a little bit more difficult and things that people usually make mistakes on. For instance, what happens when you have a couple of negatives? What happens when you're subtracting something that's already negative to begin with? And what happens when you have three numbers being added or subtracted instead of just two? So let's get into that right here. The best analogy that I can give people regarding adding and subtracting is always money, because it's something they deal with on a regular basis. Positives represent money they have, negatives represent money they owe. So, in example number 1 here, if you owe one person $21 and you owe another person $11, you owe a total of $32. And what that means, the reason this applies mathematically is they always teach you if the signs are the same, whether it's positive or negative, add the two together and then just take the sign of the numbers. And money works the same way. If you owe two people money, you could add up those amounts and that would give you the total amount of money you owe. Sort of a depressing concept whenever you owe $33 and $34 and $35, like example number 2, but it's okay. That's just the way I teach it, and I think people tend to be okay with that. So let's get into example number 2 then. You owe $33 and $34 and $35, and so basically, if you want, you can go through the process. 33 and 34 make 67, and then you've got 35 more. So if we add the total amounts together, we get 102. And since all of the amounts were negative, that means we are at negative 102. All right, let's get into example number 3. 15, and then you are subtracting a negative 45. So 15 minus a negative 45. Hopefully you've practiced this over time, and hopefully you end up finding out that this is the same thing as 15 plus 45, and you end up getting 60. What's really happening here is if you turn yourself around, if you make a 180-degree turn and you're facing the opposite direction and then you take another opposite, you're right back where you started. This sign is an opposite sign, and so is this. And if you are told to do the opposite of the opposite, those two opposites cancel out. So that's what we're doing here, and I think most of you know that, so we're going to move on. 233 plus a negative 222. This is one of those things, it is really funny to watch 8th graders work because they get a problem like this, and then they get a problem like this. And some 8th graders have been taught that they have to write it like the first model there. And some teachers teach it that way. Some students learn it that way. They find something on the internet that helps them remember that way. I don't understand the complication. To me, I think of it again just like money. You have 233, you owe 222, so you have $11 left. That's me. And I don't know, again, if that analogy helps anybody, but I certainly think it's better than having to worry about the signs. Now, whatever work you're being told to show by your teacher, you got to go with that, and whatever helps you remember, I think you should go with that. But again, I think of it just in terms of money and that sort of thing. All right, example number 5, we've got 374, we've got 222. Once again, you're talking about two negatives. 374 minus something that's already negative to begin with. That means the negatives are going to go away when it's all said and done. We are just going to add. So that looks to me like we've got 596. All right, example number 6. Let's get into problems with 3 different real numbers involved. We've got 99 and we're taking away negative 33. So again, if your trick is just to change these into plus signs, that's great. That is basically what we're talking about here. 99 plus 33 is 132. And then you could either treat it as 132 minus 66, or again, some teachers emphasize the fact that you're really just adding a negative. These are all the same thing. It doesn't matter a lot to me as long as you get it right. If you look at it from the money perspective, if you have $132 and you spend 66, you still have 66 left. So you have spent half of your money. You've got the other half left. All right, example number 7. The biggest key here is just to make sure that you line things up the best that you can. Doesn't really matter how you line it up as long as you make sure the decimals work together to get you the answer you're looking for here. It doesn't matter if you put the second on top of the first on top of the second. We've talked about that before. That is the commutative property. Anyway, it looks to me like 11.451 will do the trick. All right, let's get to example number 8 here. You've got -5 and 17/100ths, -1 and 11/100ths. Now, hopefully you remember that trick we talked about before, or you can just think of it in terms of common sense. When you owe money and you owe more money, now you owe a lot of money. Another way of looking at it, you can just add the two numbers, and then when you're done, make it negative. Whenever you have two numbers that have the same sign, you can just add them together and then bring the sign down at the end. In this case, there's no carrying, there's nothing that needs to be done extra, so I'm pretty much just going to go through this and do it in my head, and I'm going to get that. So if you owe $5 and then you owe another $1, now you owe $6, so that seems pretty reasonable to me. All right, example number 9. So you're changing these to positives because you're doing the opposite of the opposite. And I tried to make this problem one of those where it might look a little bit more intimidating than it really is, because the answer is 4. All right, example number 10. We have a common denominator of 9. So all you have to do is add the numerators and subtract the numerators as you go. 1/9 plus 3/9 is 4/9. And then you take away 5/9. Keep in mind now you owe more than you have. You are taking away more than you have, which means your answer when it's all said and done will be negative. All right, example number 11. So you've got 2/3, 3/11, and 1/3. Now, you could get a common denominator first, or you could take the 2/3 and the 1/3, deal with them. There are a lot of different ways to approach this. I'm just going to take it straight left to right, and obviously, you might think there are better ways to do it, and there might be, but I just want to make sure we practice getting a common denominator first and then getting it done from there. All right, so if I want to turn a 3 into a 33, I'm going to multiply it by 11. Whatever you do to the bottom, you got to do to the top, and that gets me this. Same thing over here. To get a common denominator, I'm going to multiply the top and the bottom by 3. And then, same thing for a common denominator. I'm going to multiply the top and the bottom by 11. And when it's all said and done, that's going to give me 31 over 33 minus 11 over 33. And then you could just subtract the numerators, and that would give you a final answer of 20 over 33. All right, last but not least, example number 12, we need a common denominator, and a lot of times people get thrown off on a problem that has a whole number or a natural number or an integer or whatever variety you want to call it. We need to make sure that we consider that being over 1 and then get a common denominator on that particular term as well. So in this case, 1, 2, and 3. If I want to make a common denominator out of the 3 of these, the common denominator is going to be 6. So we'll start with these first two, and we are going to get 15 times 6, which would be 90 over 6. 90 over 6 is the same as 15. Now, to turn a 2 into a 6, you need to multiply by 3. Whatever you do to the bottom, you've got to do to the top. That would give you 45 over 6. And then last but not least, we are going to multiply the final fraction by 2 on top and on bottom, because it turns out 15 over 3 is the same as 30 over 6. Now, you could have looked at that and said, well, we know that 15 over 3 is just 5. Yeah, put that one in there because I wanted to make sure we had something that would reduce in the end. Because a lot of times people will get through a problem like this and they will say, well, 90 minus 45 minus 30 is 15 over 6, and then they will just want to quit. But in the end, I do want to make sure that we get good at reducing as well. So make sure you reduce your final answer by 3 because the top and the bottom are both divisible by 3, which means the answer is going to be 5 over 2. All right, thanks for joining me today. I hope this helps, and good luck the rest of the way.